In this video, we are going to talk about the two supporting teats for our Composing and Decomposing Area unit, 3.6D and 3.6E. Now, there are a couple of things that second grade students do to support this unit. So for 3.6D, second grade students in their standard 2.9F are required to use concrete models to find the area of a rectangle. They cover it with no gaps or overlaps, and they just count to find the total number of square units. So that we talked about in our area and perimeter unit, that is all that second grade students have done for area. So we're going to start with that and talk about, in addition to what we've already done with area of rectangles and squares, what are we required to do in this unit? So in this unit, students understand that at times multiple figures have been joined together to create a composite figure. So we're working with composite figures, and that just means two or more rectangles or squares have been put together to create one figure, and we have to break that apart into its figures to be able to find the area. So it says decompose composite figures formed by rectangles. Remember that a rectangle can also be its special friend. A square would be included in that. Into non-overlapping, so they're decomposing into non-overlapping rectangles to determine the area of the original figure using the additive property of area. That just means once I take that shape and break it into its parts to find the area of each part, I have to add them back together to find the area of the total. Additive property of area. So let's look at a couple of different questions, because I want you to see the different levels of questions we might see with this. So in this question, the students were given the two parts. It's already been broken into two parts for them. Notice they're given the line. Here's the line. Find the area of this part, find the area of this part, give the total. They're even told there's a rectangle section and a square section. Find the total. Now, in this question, they're not told that. They're just told, here's the floor. It's composed of two rectangles. What's the area? And it's a griddable. So in this question, students have a choice. They could break it right here, or they could break it right here. So I could find this long rectangle and this long rectangle, or I could find this top part and this, or I could do three separate parts. So students are given a choice in this one. They're not given the support of breaking it into the parts for them. And again, it's a griddable. So we have to make sure we're doing a variety of activities that allow students to move from broken up for them to not broken up for them. Multiple choice to open-ended. So we want to make sure there's a lot of variety in what we are expecting students to use. What we want students to understand is it doesn't matter how I break that composite figure up, as long as I've calculated the area of each part correctly and put them back together, the area is the same because the shape didn't change. So we want them to understand they can choose to break it up however they would like, as long as they calculate each part correctly and the additive property of area, putting it all back together correctly. So we also want to make sure that students are always writing the unit with the measurement. So we don't want them to just say this has an area of 18. 18 what? 18 miles, 18 square miles, 18 square inches, 18 square centimeters, 18 square millimeters, 18 square yards, 18 what? So we want to make sure we're being specific. We also want to make sure that for area we're always using square units, because every one of these, to find area, we're talking about it being covered in square. In this particular case, square yards. How many square yards did it take? In this case, square feet. How many square feet did it take? So it's always square. We don't want it to just say the total area of this garden is however many feet. It's not 56 feet. That's linear. Square feet is area. So we want to make sure we're using those correct academic vocabulary as well. And we want to let kids explore lots of ways to decompose these composite figures when they're finding the area. There's an activity on our Google Drive that is a great way to do that we looked at our last C&P together. Now, we also have to remember that when we're given these, we might be given a figure that has some missing sides, that they have to use the information in the figure to find the sides before they can calculate that information. So you'll just want to make sure there's a lot of variety in what you're presenting to kids. Then in 3.6e, this one ties our understanding of area with our understanding of equal parts or fractional parts. So here we're decomposing two congruent 2D figures. Notice they're congruent. Two congruent 2D figures. And we're going to decompose those into parts with equal areas and express the area as a unit fraction of the whole. And we'll talk about what that means. And recognize that equal shares of the whole don't have to have the same shape. So first of all, in second grade, 2.3a and 2.3d are the supporting standards. And in those two standards, students partitioned objects into equal parts and they named the parts. They did halves, fourths, and eighths. So in this particular standard, students are expected to decompose those into equal areas. So let's look at a question to help make sense of that. So here's the standard. Decompose two congruent two-dimensional figures. We have two congruent squares here into parts with equal areas and express the area of each part as a unit fraction. Remember, a unit fraction is just a fraction that the numerator is 1. A unit fraction of the whole, and recognize that that equal shares of identical wholes need not have the same shape. So let's just ignore our answer choices for a minute and just look at what they're asking us to do. So Brandon drew these two congruent squares. He divided one into two congruent triangular parts. So that would be diagonally. He divided the other into two congruent rectangular parts. Well, I could do that horizontal or vertical. It doesn't matter because it would still be two congruent rectangle parts. So let's talk about this for a second. What part of the whole is this triangle? It's 1/2. What part of the whole is this triangle? It's 1/2. What part of the whole is this triangle? It's 1/2. What part of the whole is, I said triangle, rectangle. What part of the whole is this rectangle? It's 1/2. So this 1/2 is equal to this rectangular 1/2 because we started with congruent wholes. So I took half of this square and half of this square. These are equal. That takes time for kids to understand. The best way to develop this understanding is through doing activities with paper where they can fold it and cut it and prove it. So we're going to do that. So here I have two square pieces of patty paper. So if I do what this says in this problem, he divided one square into two congruent triangular parts. Okay, and he took the other one and divided it into two congruent rectangular parts. Now, kids don't believe you just because you said that these are equal. You and I know they're equal because the squares started out equal. Half of this one is equal to half of this one, however I get the half. But if we do the activity where we let them cut this and prove that they're equal, so if I cut this on the diagonal line that I made, they still don't think that these two parts are equal, right? Because they're not the same. In their mind, they're different shapes, so they can't be equal. I didn't cut that perfectly. But if I fold this and cut it again so that I can make the rectangle, and I'm going to pause and do that so that the video is not so long. Okay, so here's this half, and all I did was take one of the triangles, I folded it in half and cut it, and then I folded that in half and cut it. So I have the 4 triangles, and then watch this. I can lay them here and prove to you that these are equal. Because they take up the same space. Kids need to see you do this, and they need to do it themselves to understand that this half is equal to this half. They're not going to believe you just because you said so. Well, they might, but they haven't built the learning if they're only believing you because you said so. They need to do it themselves to understand why these parts are equal, because they take up the same amount of area. That's why these two things are connected. This is area. They have the same area. Just because, oh, you can't see it. Just because they're not the same shape does not mean they don't have the same area. So if you need help with that, please let me know.